Have you ever looked at your computer or your phone and just wondered, how does it know what to do? How do we give it commands? Well, today we're going to pull back the curtain on all of that. We're going to break down the absolute fundamentals of programming using one of the world's most popular languages, Java. So let's get right into it. So here's the big challenge, right? There's this huge communication gap between us and our machines. We need a way to give them instructions, to tell them exactly what we want them to do. But how do we speak a language that a machine can actually understand? And you can see the difference right here. Our languages, like English or Hindi, are incredibly complex. They're full of subtle meanings and emotion. Computers, on the other hand, their language is dead simple. It's direct, they don't get sarcasm or context, they only understand absolute crystal clear commands.
Well, that simple language has a name. It's called binary. You see, at its very core, a computer is just a massive collection of tiny electronic switches. So its entire language is built on just two states. When a switch is on and electricity is flowing, that's a 1. When it's off and there's no current, that's a 0. Every single thing a computer does is just a unique, long pattern of these 1s and 0s.
All right, so here's our game plan for today. We're going to talk about that communication barrier, then see how Java acts like a universal translator. We'll cover why planning is so important, get our toolkit set up, write our very first piece of code, and then we'll take a peek under the hood to see how it all actually works. So we have to find a way to bridge that gap between our complex human thoughts and the computer's simple on or off world. And that is exactly where something called a high-level language, like Java, comes into play. You can think of it as our universal translator. And trust me, we need a translator. Could you imagine trying to write a simple math problem like 53 plus 72 using nothing but long strings of 1s and 0s? It would be an absolute nightmare. So tedious, and you'd make mistakes constantly. We really need a better way to give our instructions. And that's where the compiler comes in. A compiler is basically a special program that does all the hard translation work for us. We write our instructions in a language like Java, which is much, much closer to English, and the compiler does the heavy lifting of turning it all into the binary code the computer needs. But hold on, before we even start writing and translating, we need to know what we want to say. You know, programming isn't just about the language, it's about the logic. You have to have a clear step-by-step plan. It's kind of like having a blueprint before you build a house, or a recipe before you start cooking. Let's use a super simple, real-world example, making instant noodles. You don't just randomly throw things in a pot, right? No, you follow a clear sequence. You start, you get your ingredients, you combine and boil them. Then you have a decision point. Is it cooked? If not, you keep boiling. If yes, you serve it. That logical, step-by-step process, that's the heart of programming. Now, we can apply that exact same thinking to a coding problem. Let's say we want to add two numbers. The flow is almost identical. We start the program, we get the two numbers we need, we do the calculation, and then we display the final answer. See? It's the same kind of step-by-step thinking, just for a digital task. And you know, this process of writing out your plan in simple, plain English actually has a name in the coding world. It's called pseudocode. It's that perfect middle step between your idea and the actual code. It lets you work out all the logical kinks before you have to worry about the specific rules of a language like Java. Okay, so we've got our logical plan. Now it's time to actually get our hands dirty. To write and run Java code, we just need to set up our digital workshop with a couple of key tools. First up, you need something called the Java Development Kit, or JDK. Think of this as the engine. It has the compiler and all the other core tools you need to actually process Java code. Second, you need a code editor. This is like your notebook or your word processor, a program like Visual Studio Code where you'll actually type out all of your instructions. All right, with our tools all set up, we are ready for the magic moment. It's a long-standing tradition in programming that the very first thing you write is a program that just makes the computer display the words "Hello World." It seems small, but it's that amazing first step where your instructions finally come to life. Now, as we look at this code for the first time, don't worry if it looks a little weird or confusing. Seriously, learning to code is just like learning any new spoken language. At first, the grammar and the vocabulary feel totally foreign, but if you stick with it, you start to see the patterns, and pretty soon it all starts to click. So pretty much every Java program follows the same basic template. It starts with something called a class. You can think of that as the main container for your whole program, like a kitchen. And inside that kitchen, you have functions, which are like individual jars that hold instructions for specific tasks. The most important one is called the main function. That's always where the computer starts reading your code.
And here it is, our very first Java program. You can see the container, our class, and inside of that, you can see the main function where everything kicks off. And that one line in the middle, system.out.println hello world. That is our instruction. We are literally telling the system to print a line with the words hello world on the screen. And when we run that code, boom, this is what we get. That simple two-word phrase pops up on the screen. And that right there, that's the magic of coding. You've turned a few lines of text into a real, actual output. You've just given the computer its first command. So, how did that just happen? What was going on behind the scenes to turn our text file into those words on the screen? Let's quickly pull back the curtain on the two-step journey that every piece of Java code takes. Step 1 is compilation. We take our human-readable file, the one that ends in .java, and we feed it to the compiler that came with our JDK. The compiler then translates our code into an intermediate language called bytecode. This process creates a brand new file, this time ending in .class. Now for step 2, execution. That new .class file, our bytecode, gets handed over to something called the Java Virtual Machine, or JVM. The JVM is like the final local translator. It reads the universal bytecode and translates it one last time into the specific native code, the actual ones and zeros that your specific computer can understand and run. And this whole two-step process, well, that's Java's superpower. It's what we call portability. Because that final translation is handled by the JVM on each separate machine, it means you can write your code just one time, compile it into bytecode, and then that same bytecode file can run anywhere, on a Windows PC, a Mac, a Linux machine, you name it. This is the famous write once, run anywhere idea that made Java a total game changer. So let's do a quick recap of everything we've covered. At the end of the day, programming is really just about giving a computer clear, logical instructions. High-level languages like Java are the amazing translators that make that conversation possible. Remember, a good plan is the foundation for any good code. And, most importantly, you've now seen with your own eyes how just a few lines of text can make a computer do something real. You've taken your very first step. You've learned how to say hello and make a computer listen to you. From this point on, the possibilities are literally endless. So the only real question left is, what will you tell it to do next?